Here we are virtually at the top of Mount Bonnell. Mount Bonnell is not the highest topographic spot in the city of Austin. Mount Barker is just over on the other side of the hill, and you can look up and see that there's a mini mesa over there with a house or two built up on it. But you get a pretty good view anyhow. You know, we're looking down. If we move around a little bit, you can see the escarpment goes under an arm of the lake, and if you're in the right position, you can see where Tom Miller Dam is. You can see the spillway elevations on Tom Miller Dam, and the fault comes up and runs up above the beginning of the impounded level of Ladybird Lake, and we have this high country. The areas west of the Balcones Fault Zone and Escarpment have been uplifted, and the areas on the downside, which is the southeast side of the fault plain, has been dropped down. So we don't attribute, you know, that it's all uplift or all down warping, but both are going on. The city of Austin is here because of Mount Bonnell. This is the reason that people settled here. That Mirabeau Lamar was the president of the Republic of Texas before Austin was even anything more than just a spot on the map. That was all. It was widely regarded as being favorable by virtue of the fact that you've got a perennial river going through, prolific artesian springs, Barton Springs, for example, and it was away from the Texas Gulf Coast with mosquito-infested swamps and things. So we have mosquitoes enough as it is in Austin, but it's not as bad as you would have it if you were down in the tidelands of Houston. It's the beginning of the American West. You have the water coming out the base of the escarpment. You have the agricultural produce coming out from the Blacklands to the east, and you have livestock being produced from the west side of the Balcones Escarpment. So anyhow, this sign, we're real proud of this. There's the topography. Look at the density of those contour lines there. What does that mean to you when you see dense contour lines? Certainly steep slopes. Steep slopes, yeah. So the relief here is not all that great. You're dealing with something that is, you know, several hundred feet of relief, but it's not like, again, we're not like the Alps or something like that, but still these drainage ways are cut into this, multiple drainage ways, and what do they do? What hazard do they present to you?
Flooding. Flooding,
absolutely. And so you have all of these high gradient streams coming off of this sort of plateau remnants up here. The true Edwards Plateau is about 60 or 70 miles west of here. But you have these remnants up here, a continuous remnant that goes across the drainage divide between flow to the Colorado River and flow going to the north to the Brazos. It's amazing to have the main trunk stream of the Colorado River within that sort of dimension in terms of its getting on the other side of the next divide over, flow to the Brazos River. All of this, all the way across the lake, was once connected as a plateau-like upland. So it was all part of the Edwards Plateau that went all the way to where we see it today over near Johnson City. And since that time, we've had the Balcones Fault events, which is on the order of 15 to 20 million years, which set in motion the deep incision by these surface watersheds and streams. So it certainly had a long time to do it, but even for a geologist like myself, I have a hard time sometimes grasping that you had that plateau terrain that went across where the river is today, and because of that faulting 15 or 20 million years ago, these streams were given the impetus to cut down, and their tributaries cut down, and it gave you that landform map that we see right there. Here we are really at the apex, at the summit of Mount Bonnell, and we're looking straight across Lake Austin, and we're seeing over there where the transmission towers are, 3 of them rising up over there on Mount Larson, I believe it is, then several more over here, 1, 2, 3, 4, 5, 6, 7. Those that are standing up on little mesas, those are on the basal 15 or 20 feet of Edwards limestone. That's steep ground going over there, and you'd have a lot of runoff when you have these heavy rains. And those low water crossings, they warn you, don't drive into it. Well, please don't, because 2 feet of flow on a pavement can pick up a car and carry it off. Let me just reiterate that those flat top mesas there where the transmission towers are, or where the ones are on the sort of mini mesas, the bit of high ground, that was continuous. It didn't have breaks in it. It came over and was continuous all the way over to here and all the way up to the flat top horizon over there. So this was all part of the Edwards Plateau, which is this amazingly extensive landform that goes all the way into West Texas. After faulting, the rivers cut down, tried to get down to the level where they are now, and the tributaries etched their way up onto the high ground. And you can really see that when we move down to our next stop. You can see the Pennybacker Bridge over there in front of where the bend goes around, and there's a light colored, looks like newly constructed building there, and the Pennybacker Bridge is straight ahead from that. And you've got that big road cut over there that's cut through the Glen Rose limestone over in that area. But look at the horizon. The horizon is almost flat. Some of it is kind of like a perspective that you're having to kind of look past the promontory that's coming our way, and then you have that straight horizon, and that horizon is underlain by Edwards limestone, and it has not been cut into in a sort of appreciable way. And again, you're down here on the lower slopes. There isn't as much runoff, but there on the other side of the river, you can see how steep that terrain is over in the area behind the Pennybacker Bridge. It's a good show.